Hi friend, you are welcome back to my channel. In this very video, we shall be learning about simple pendulum. We shall be learning something important about simple pendulum. Alright? Here is the diagram we shall be making use of for the purpose of this very discourse. Okay? Now first thing first, note that the motion of a simple pendulum, is simple harmonic motion. The motion of a simple pendulum, like I said, is simple harmonic motion. Simple harmonic motion is a simple harmonic motion. Alright? Now apart from that, there is something I want us to use this diagram to explain. Now if you notice, at this very point, the ball was released, it swings through and fro. To and fro, right? Now if you notice, there is a height difference between this level and this level. There is a height difference. So what do you notice? The ball was at one extreme end, it passes through the lowest point, and then it goes to the other extreme end, it comes back again, passes through the lowest point, and then got back to the first extreme end. Now there are a number of energy changes that occur as the ball swings to and fro, and questions do arise from this very aspect of simple harmonic motion, which we call simple pendulum. So for the purpose of this discourse, we'll be making use of a table to summarize all we shall be learning. Okay? We'll be making use of a table to summarize all we shall be learning in this very video. Alright? So let's call this point. Now what happened at point A? Okay? Now what happened to the energy, kinetic energy? What happens to the potential energy? Alright? What happens to velocity? And lastly, what happens to acceleration? All these must be known by heart. Okay? All this must be known by heart. Now let's continue. At this very point, we notice that this guy seems to be at a height with reference to this. At this very point, the bulb, okay, the simple pendulum bulb seems to be at a height with reference to this. It's just like saying someone is at a height. Let's say this marker at this very height from the ground level. Okay? What form of energy does this marker possess with respect to the ground? Is what? Potential energy. So at this very height, with respect to this position B, this bulb has potential energy. So we'll trace it. Potential energy. And take note that at this very height, this bulb has maximum potential energy. Are we together? Now if you check at this very highest point, the bulb is not moving either this way or this way. Okay? It's kind of static for some second. At that very point, there is no motion. Okay? Like saying it swings. When it gets here, it could not go any further. It was static for some moment at position A, either of them. Now at that point where there is no motion, we can say that the kinetic energy is what? Zero. Are you seeing that? Now what also happened at this very point? There was no velocity. Is it not? That's why the ball could not go beyond this. Velocity was zero. So we had velocity was what? Zero. Now at this very point, because of the potential energy this guy possesses, he has what they call maximum acceleration. Okay? Maximum acceleration. So we write that acceleration is maximum at this very point. Alright? This must be noted for a simple pendulum. Now at position B, when it now starts descending, because of the maximum acceleration that it has, this potential energy will now be converted. It's now being converted to what? Kinetic energy, such that at the lowest point, kinetic energy is maximum. And at the lowest point, potential energy is used up. So it's what? Zero. At this very lowest point, the bulb has maximum velocity. So as it's passing through this very point, the velocity is what? Maximum. Alright? And at this very point, the acceleration has been used up. So the bulb literally has zero acceleration. Now why is this table very important? Because questions do arise from this aspect of simple pendulum. They will draw a diagram like this, and they'll be like, okay, at what point is the potential energy maximum? The answer will be what? Point A. These two extreme ends. Now at what point is the velocity equals to 0? It's also what? At point A. So using this diagram and this table, you are good to go for any question that relates to what? Energy changes for simple pendulum. Okay? I hope you find this video lesson helpful. I will see you guys in the next video.